Welcome to Brain Vision.
Okay, let's start by going over the constants given to us. So the mass of the pan is 0.2 kilograms. Mass of the steak is 2.2 kilograms. K equals 400 newtons per meter. And the height is 0.4 meters. Okay, so we have to use kinematics to find out what the speed of the steak is before it hits the pan. Well, we know that V final squared equals V initial squared plus 2AH. So V initial is 0 in this case. It's dropped from rest. So then we can plug in 2AH. So this is 2 times 9.8 times 0.4. Okay, and we can take the square root of both sides. And we get that the velocity of the steak, so it's the final velocity in this kinematic equation, the velocity of the steak is 2.8 meters per second. Now we have to do a little bit of momentum work to figure out what the mass of the steak and the pan together are. Okay, are they, once they strike and stick to each other. So if we write our momentum equation out, we have that the mass of the steak times the speed of the steak plus the mass of the pan times the speed of the pan equals the total mass times the total velocity. Okay, well, the mass of the pan is 0. So what we end up with is that V will equal ms Vs over the total mass. So this is 2.2 times 2.8 over 2.4, which equals 2.57 meters per second. Okay, this is the speed directly after collision. So now we have to do a little bit of energy conservation. Okay. So if we write out the energy before and the energy after, so that we initially start out with kinetic, so that's 1/2 mv squared, and spring potential because the spring is extended. And we finish with the spring being fully compressed and not moving, so that is 1/2 Ka squared, where A is the amplitude of the spring. All right, so if we rearrange this for A, we get that A equals the square root mv squared. We could drop the 1/2s everywhere, plus kx squared. I'm going to call this x naught because it's some initial extension over k. Okay. We know that k times x naught equals the mass of the steak times gravity. So x naught okay, so then we could replace x naught for this quantity here. We have the square root mv squared plus k msg over k squared over k. If we plug all these quantities in, we get 0.21 meters. And then finally, for part C, I'm just going to put it over here. We know that the period is 2 pi square root of m over k. If we plug in the total mass 2.4 for M and 400 for K, we get 0.49 seconds.